Hello everyone. Today we are going to talk about the configuration and debugging best practice for admission webhooks. My name is Haowei Cai. I'm a software engineer at Google Cloud, and I am a member of the Kubernetes API machinery. Here's the agenda of what we will cover today. I will walk you through what are the admission webhooks and why do I want to use them, what are the best practice for configuring my admission webhooks, and what are the existing debugging methods that helps me debug my admission webhooks. In the end, I will give you a short demo about debugging a misconfigured webhook. So, what are admission webhooks? First of all, we need to understand what's the admission procedure in Kubernetes. The Kubernetes API server runs with some admission controllers by default. An admission controller is basically a piece of code that intercepts requests to Kube API server prior to the persistence of the object, but after the request was authenticated and authorized. If we take a closer look, the admission controllers can be categorized into two types: mutating admission controllers and validating admission controllers. Mutating controllers may modify the objects they admit, and validating controllers may not. If any of the controllers in either of the phase rejects the request, for example, let's see the resource quota controller rejected a request because this quota was exceeded, the entire request will get rejected and an error will be returned to the end user immediately. Other than using the built-in admission controllers, Kubernetes allows you to extend the admission control in your cluster with admission webhooks. You can configure the two built-in admission controllers called mutating admission webhooks and validating admission webhooks to talk to your own webhook backend. The mutating webhooks are called in sequence, while the validating webhooks are called in parallel. So why do I want to use admission webhooks? This is basically like why we have the built-in admission controllers. The admission webhooks can help with enforcing security policy. For example, only allow polling images from certain registries that are known to the enterprise. An admission webhook can help with governing the adherence to certain practice, like having good labels and annotations for the object. And an admission webhook can help with automating and validating the configuration of the objects in the cluster, like detecting and fixing images deployed without some semantic tags. Okay, so we understand why we may want to use admission webhooks. So let's see how to configure admission webhooks. Here's an example validating webhook configuration. I won't go to the fields, all the fields in detail. Basically, this is a webhook configuration called podpolicy.example.com. The configuration has one webhook with a rule that triggers on every namespace pod creation requests. The client config tells the API server how to talk to the webhook backend. The webhook doesn't have any side effect, and it has a 5-second timeout for the API server to call the webhook. There are some other optional fields for you to customize your webhook configuration, which are not shown here. I will explain them in more detail when we come across them in the best practice. Okay, so let's see some of the configuration best practice for admission webhooks. Here is a list of things we will talk about. Let's walk through them one by one. Idempotence. It is natural to expect the Kube API server will invoke your mutating webhook once if a request matches the admission webhook configuration. But do you know that the API server may call your mutating webhook twice for the same request? The reason for that is basically ordering mutating webhook is hard. Imagine you have two mutating webhooks. The first webhook is called inject sidecar, which injects a sidecar container to your pod. For example, here I'm creating a pod. The webhook append a sidecar container to the list of containers in the pod. The second webhook is called always pull image. It enforces a security policy in multi-tenancy scenario by setting the image pull policy to be always for all the containers in a pod. Now we have two containers in the pod, both has their image pull policy set to be always, which is great. Sorry. Imagine if the API server orders the two webhooks differently. The API server first calls the always pull image webhook, which sets the image pull policy to be always for my container. Then the API server calls the inject sidecar container webhook, which appends the sidecar container to the pod. Now the pod ends up with a container without the image pull policy set, which violates our security policy. To solve this problem, what Kube API server does is basically a best effort reinvocation to make sure every webhook sees the latest state of an object. For example, for this instance, the API server noticed that the object was mutated by the inject sidecar webhook, so it invokes the always pull image webhook again, which this time sets the image pull policy for the sidecar container. And we come to the desired state of our webhooks. Now we understand that Kube API server may call my mutating webhook twice. The best practice is for my mutating webhook to be idempotent. And an idempotent mutating webhook is able to successfully process an object it has already admitted and potentially mutated. The always pull image webhook is a good example of an idempotent webhook because applying the webhook on its output won't change the result. To give you an example of a non-idempotent webhook, imagine we still have an inject sidecar webhook, but this time the webhook appends a sidecar container to the container list with name surfaced by the current timestamp. This webhook is not idempotent because if you apply it again on the output of itself, you will end up with two sidecar containers with slightly different names. This is probably not what we wanted. Another best practice is intercepting all versions of an object. We know that Kubernetes supports multiple API versions. For example, Kube API server allows creating and updating deployments by extension v1 beta 1, apps v1 beta 1, v1 beta 2, apps v1 APIs. If a webhook is configured to only intercept deployment requests in apps v1, it will miss the requests in the other versions. So it is recommended to set the match policy to be equivalent, which this configuration ensures that the webhook will get requests that are known to equivalent from API server, and it will also ensure if a future API server upgrade happens, the APIs and the API server introduce a new version for the deployment API. For example, let's say we have apps v2, the webhook will also get the API request. Availability. It is recommended that admission webhook should evaluate API requests as soon as possible because every webhook invocation latency adds to the total API request latency. We recommend you set a small timeout for your webhook. This example sets a 2-second timeout for my webhook. If the webhook is slow and didn't evaluate the request in 2 seconds, the API server will either reject the API request or ignore the webhook invocation failure and admit the request based on the failure policy of the webhook. Guarantee the final state of the object is seen. Since we know that another webhook that is called after your mutated webhook may change the object, it is a good practice to have a validating webhook that ensures your mutation is made. If you are, say, you are using the always pull image webhook to enforce the security policy, it is recommended that you add a validate always pull image webhook, which makes sure the image pull policy is set for all the containers in your pod. Side effects. So some admission webhook may mutate related resource as part of the request processing. For example, the resource quota, a resource quota webhook may increment the quota usage when it admits API requests that consumes the quota. The best practice is to avoid side effects if possible. If a side effect is required for your admission webhook, make sure to have a reconciliation mechanism. For example, a controller that decreases the quota usage in case the request didn't make through because it was rejected by something else in the admission chain. And also, don't trigger the side effects if an admission review has a dry run set. And the webhook configuration should specify its side effect to be non-dry run. Avoiding operating on the kube-system namespace. This is basically for safety purpose. The kube-system namespace hosts system critical components. For example, the Kube API server itself has some post-start hooks that bootstraps the internal controllers. If your admission webhook rejects the request in kube-system namespace, it may cause the Kube API server to be not healthy. Also, the namespace hosts objects for control plane components. For example, the service account for all the control plane components and the pod like kubedns. If your admission webhook is not intended to modify the Kubernetes control plane behavior, it's recommended that you exclude the kube-system namespace using a namespace selector or an object selector. For example, here is an object selector that only matches the namespace, only matches the request in a namespace that doesn't have a run level with value 0 or 1. Also, excluding kube-system namespace makes both API server and the webhook's backend more efficiency because, as we mentioned before, every webhook invocation latency builds up the entire API request latency. Now, by excluding the kube-system namespace, the webhook invocation is scoped to only what is needed. Now we've looked at some of the configuration best practice for admission webhooks. How do we debug our admission webhooks? Before looking at some of the existing debugging methods, let's first take a look at the ways that admission webhook invocation may fail. This is the table of types of webhook failure or rejection. I tend to think them in 3 different categories. The first category is actually a valid webhook rejection. For example, a Kubernetes API server sends an admission review to the webhook backend, and the backend determines the request is invalid and responded with a 400 or 403. In this case, the API server surfaced the responded HTTP code to the client. So for example, the end user who originally sent the request will get a 403 forbidden. Another valid webhook rejection is actually a 500 internal error to the webhook backend. If the webhook backend hits the internal error but is still able to compose an admission response, it will send the API server a 500 internal error. In this case, the API server will also surface the error to the end user. So the end user will get a 500 and specifying the webhook denied the request. The second category of webhook failure is error calling webhook. For example, if the webhook backend is too slow and timed out, or the API server just failed to establish a connection to talk to the webhook backend, or if the webhook sent back the admission response, but the API server failed to parse it because the response was malformed. In this case, the API server will return to the end user a 500 internal error and potentially a reason explain the error. The last category is the actual API server internal error. This should rarely or never happen in reality, but I'm just listing it here in case that we have a programming error in Kubernetes that the API server panicked. In this case, the API server will also return a 500 to the end user. To just make the table a little bit more complex, in the webhook configuration, for each webhook, it can configure a failure policy. In V1 API, the value is default to be reject, but you can configure it to be ignored when you start a webhook. In that case, if an error calling webhook occurred, for example, timeout, connection failure, malformed response, the API server will ignore the webhook invocation failure and return no error to the end user. So you may notice that all three categories may end up with a 500 response to the end user. For a single webhook failure, you may be able to tell what actually happened from reading the reason in the returned error. But imagine you are monitoring all the traffic in the cluster and you see a surge of 500 when you are developing your webhook. How would you be able to tell what kind of failure happened to what webhooks? We have some metrics for answer the question. The Kube's API server serves Prometheus metrics on its /metrics endpoint, which reports data status about itself. Among all the metrics reported, there are two metrics that are related to admission webhook invocations. One is called admission webhook admission duration, which is a histogram metrics that basically tells you how long admission webhook invocation typically take. Another metric is called admission webhook rejection count, which is a counter matrix that tells you how many rejection or webhook failure happened grouped by the webhook name, the API request operation type, the type of the webhook itself, so validating or mutating, the error type, basically the three categories we mentioned before, and the rejection code, which is if a webhook did a valid HTTP status code rejection, it will be reported here. To just give you a quick example of how the metrics may look like, here's a metrics output I got from running some basic Kubernetes E3 test. Basically, it shows you that there were 3 error calling webhook occurrence from the 3 line with the highlights. In the bottom, there are some webhook rejection with no error, so that's a valid webhook rejection, and you can tell from the status code that the webhook rejected the request with 400. Sometimes you may want to debug some non-obvious webhook behavior other than basic monitoring the cluster. For example, you can tell that your webhook backend was processing admission review and mutating the object, but it seems to be ignored from the API server point of view, and the result object never got mutated. Or you find that your webhook backend was processing the review and the API server did mutate the object, but it was in a different way that you would expect it. Could it be a bug in your webhook backend? Could it be a bug in the API server? Or could it be some other mutating webhook that changed the object after your mutating webhook? We have audit logging to answer this kind of question. Based on the documentation, Kubernetes audit logging helps the cluster admin answer the following questions: what happened, when did it happen, who initiated it, etc. to just give you a quick view of how Kubernetes audit logging works, here is a audit policy that sets the Kubernetes API server to log pod changes at request response level and log pod/log and pod/status sub-resource requests at metadata level. And I just pulled some random audit log record from my cluster. Here is a record. The record is actually called an event. It's defined under audit.case.io v1 API version. This is a metadata level audit record, so you won't be able to see what was actually in the request. But basically, this tells us someone was creating a Kubernetes event in the kube-system namespace. The creator was someone called the kube scheduler, and we have some other metadata level information, for example, the timestamps. Now let's take a look at how Kube API server leverages the audit logging to record activities related to mutating webhooks. Basically, there's a field in the audit record called annotation, which you would imagine is basically a map of key value pairs that allows plugins in Kube API server, for example, authentication, authorization, admission, to customize the audit records with their own information that they want to record. The admission webhooks use the two types of annotation keys to record mutating webhook events. I will go through the definition of them in more detail, but the prefix, the annotation key basically differs in the prefix. One starts with mutation and one starts with patch. Here's an example of an annotation audit event that has this annotation, and you can see there is a key called mutation.webhook.admission.case.io/round1index2. This is logging an activity related to a mutating webhook. So let's take a look at how these annotations are defined. The first annotation key records a mutating webhook occurrence. The key starts with the word mutation, followed by webhook.admission.case.io, round number and index number. For example, round 0 and index 1. The numbers are 0 indexed. So this number means this is a activity record for a mutating webhook that happens in the first webhook invocation round, and it was the second webhook in the list of mutating webhooks. This type of annotation is recorded if the audit level is set to be metadata or higher. The value of the annotation is a JSON blob with 3 fields: the configuration, the webhook configuration name, the webhook name, and a mutated, which is Boolean that tells if the patch sent by the mutating webhook actually changed the object or not. The other annotation key starts with the word patch, followed by the same thing. And just give you another example, round 1 index 3 means this is a webhook activity that happens in the second round, which is the reinvocation round, and this is the 4th mutated webhook in the mutated webhook list. This annotation is recorded if the audit level in the cluster is set to be request or higher. The value of the annotation is a JSON blob with 4 fields: the webhook configuration name, the webhook name, the patch type, which is JSON patch in this case, and the actual JSON patch sent from the mutating webhook. As you can see, this mutating webhook was trying to set the value under /data/mutation stage to be yes. Just to give you an example of how this annotation would look like, this is the actual annotation, actual audit event that I captured from my cluster. As you can see, there are a lot of annotation with this prefix. This is from also from a Kubernetes E3 test. So there were a lot of webhooks that are trying to do mutation. And you can see both the mutation and the patch annotation were recorded. Last but not least, you can always debug your own webhook backend. The previous methods like metrics and audit log helps you if you are suspecting something was wrong on the Kube API server side, and without them, the Kube API server feels more like a black box to you. But you could always have good logging in the admission webhook backend that you deployed, so you can have a better view of, say, what admission review the backend got from the API server and what admission response it responded to the API server. Okay, I will give a quick demo about how to debug a misconfigured admission webhook using the audit log. The demo is pretty simple, so I just captured some screenshot. Say I was developing admission webhook in my cluster, and I was happy. All of a sudden, the cluster breaks. I cannot apply the pod anymore. The API server just responded with, my pod is invalid. It tells me that there's a duplicate value my sidecar in the container list. So basically, this is a duplicate name in the list of container. The response is a valid legit Kubernetes rejection because the Kube API server tries to make sure in the pod all the container names are unique. So I recognize this my sidecar name. This should be injected by my inject sidecar webhook. So I just take a look at what are the mutating webhooks there in the cluster. I found that the inject sidecar webhook has been working for a week, but it suddenly breaks after I deploy the other webhook. Luckily, I have the audit log enabled for my local cluster. So here I configure it to log activity at request level. And I basically try to grab the latest request to the pod creation endpoint. Since I know there's no one else doing pod creation in my cluster as I was developing myself, I just grabbed the latest one and try to see what was there. The actual audit event is pretty long, so I split it into some pieces. First, this is giving me the metadata of this event. Basically, it was saying I was creating the pod using kubectl. The pod is called my pod. These are all expected. And later, it shows the API server responded as a 422, which is also a legit rejection from API server point of view. Later on, I see the original request sent from kubectl, which only includes a container called my container, so there's no injected sidecar container yet. These are still all expected requests from kubectl. But after that, we see there are some annotations that are recorded by the Kube API server. So here we can see that there are 3 webhooks mutated the object. If you look at the mutation webhook admission round 0, index 0, you can see my inject sidecar webhook tried to inject a sidecar container to the pod, and it successfully mutated the webhook. And after that, at position 1, there's the other webhook mutated the pod again. And later on, the API server tried to re-invoke the inject sidecar webhook, and the inject sidecar webhook mutated the object for the second time. And we can also see what the actual patch is from the patch annotation. Basically, from this point, I see the problem is that my inject sidecar webhook was not idempotent. it was appending a sidecar container to the pod, regardless of if there is a sidecar container in the pod already. So I tend to fix the webhook backend by first detect if there is a sidecar container already in the pod. If not, inject sidecar, otherwise just skip the admission response and send an empty patch. So now my webhook is idempotent and everything is happy again. Okay, so the key takeaways from this session is that configure your admission webhooks following the best practice. We also have a documentation describing this best practice on the website, and use the metrics and audit logging to monitor and debug your webhooks. Thank you. Is there any questions?
Thank you so much, Haowei. Any questions in the audience? There's an open mic.
Could you elaborate a little bit on what is the system requirement in order to configure webhook and the administration control?
Admission webhook was brought to V1 in 1.16, and also the admission webhook rejection count and the audit logging are introduced in 1.16 as well. So all these.
But my question is more specific on, I'm installing a new cluster from scratch and I'd like to start configuring it. So what would that consist of?
You need to, so the question was how do you bring up admission webhook in a cluster starting from scratch? You basically need to deploy a webhook backend. It can be deployed in a pod. It can be a URL that from your own server backend, and you need to deploy an admission webhook configuration, either for the mutating one or for the validating one, to help the API server to be able to talk to your webhook backend. And also, there are some feature gates that you need to think. You need to enable the built-in admission controllers, which are enabled by default. So those two admission controllers called mutating admission webhooks and validating admission webhooks.
And from an RBAC perspective, do you need to have system cluster admin role or something like that, or?
Yes. Enabling admission controllers, which even though they are enabled by default for those two controllers that I mentioned, this action is a cluster admin level action because it's at the time that you bring up the Kube API server. Creating the admission configuration, admission webhook configurations is more based on the RBAC rule, but it's also tend to be at clustering admission level.
So is it fair to assume that this use case is not for main developer, but more like cluster administration that's trying to provide infrastructure?
Yeah, you can only deploy admission webhook if the cluster admin grants you the RBAC rule to be able to create those configurations. So yes.
Thank you.
One more short question. Who has a short question? Well.
Thank you. Is it safe to run a webhook on the cluster that it's going to apply to, or is there a danger that you'll lock yourself out if you get that wrong?
There are potential risks that if your webhook, yes, it's okay to deploy your webhook backend in your cluster by pod, but there are potential risks that you can deadlock your webhook if you do something wrong, like say if your webhook is admitting pod-related, deployment-related request, and you found the bugging itself, and you are trying to update the backend. Basically, you are trying to update the deployment of your webhook backend, but it's already up there, and the bug caused it to reject the pod or deployment update request to itself. Then you end up with a deadlock. So it's recommended that you use namespace selector or object selector to try to make your webhook to not admit request regarding itself to avoid this kind of deadlock.
Once again, thank you so much, Haowei. And remember to rate the session at shed.com. Thank you so much.